and why we need to reduce it. So most of the biggest companies, including mining, of course, we more know what the mining is. They commit the zero target of carbon emissions by 2050, and this is not it doesn't mean that they will produce any carbons, because I think steel, like electricity and others, will require some emissions, but they made the like kind of non-commercial company, like they call greenhouse gas, and they establish a protocol that provide the standards, guidance, and tools for businesses in all over the world and government, and to measure and manage climate warning emissions. So what does it mean? That all the companies will do step by step reducing, and I think it will start. And many of the companies, including biggest producer of steel, energy, and others, they commit that first of all, the scope 1 or step 1, work with the direct emissions from resources that they control. For example, mining, if they reduce consume diesel with the mining trucks and other equipment, they will try to reduce the amount that they consume. So the second is the indirect emissions from purchased energy. What does it mean? For example, if you buy any spare or any other part or any equipment for your own purposes, you should check how much carbon emissions the manufacturer produce when he build this equipment, for example. So this is more working with reliable suppliers, so to be sure that you buy the equipment as clean as possible. This is, really similar, for example, when you buy some products, some goods in the supermarket, and you know that it is how it goes, very clean without any nutrition add-ons and biology products and something like that. So it's more like this one, and all other indirect emissions. So when you don't directly consume, but you can influence on the environment at all. And there is a link, so if you want to get more information about this, so you can go there and check. And this is how so the net zero commitment is not only technical issue. Okay, so you need to install new equipment, and then it will produce less carbon emissions. So and it will be better. And it's all not only about the technical issues or implementing AI. This is only the part, but for example, about transparency. So, for example, when you buy or sell your products like energy or iron ore or coal or whatever, you should disclose everything, how much footprint you are making, and this should be from the very beginning of manufacturing to the final customer. And of course, focusing on absolute reduction, meaning that as much as you can reduce carbon footprint inside your company, the better. And of course, covering all resources through all these 3 steps. So it's direct, indirect, and related emissions. And okay, so today we're talking, this is in general why it's important, what are the trends in the industry, and now telling, how the AI, so because we are working, me personally and my company, my colleagues are working on IT solutions based on artificial intelligence before going, and so there is for sure like hundreds of definitions of what is artificial intelligence, but I took one of them from Gartner that so artificial intelligence, this technology that applies to advanced analytics and some machine learning and some other tools, so it can be neural networks and others, to support and automate decisions and actions. What does it mean? That still, I mean, in reality, AI cannot think by himself, but this algorithm, they help person, I mean the human, to make a decision. And yeah, of course, ChatGPT, GPT, and others, they might suppose to think by themselves, but in reality, it's just a different way to source and search the data. So, and there are a few key components of AI, and there is also one of the classification. You can do 10 of them or like hundreds of them, but in general it's machine learning, it's deep learning, neural networks, neural language processing, computer vision, and cognitive computing. Why I like put this slide here? I want to share that what Piklema is doing on that. So we work in two directions of AI. I'd like to share our real experience in mining. It's machine learning and computer vision. Okay, a little bit more about our company. So we are working on different markets and have different operations globally with the partners network. And we have like two direction of our business. The first is digital advisors for mining based on big data analytics, and the other is tires, like tires management, maintenance, all around the operation of like mining. And we have one product that is more in generation, wind power generation. We made one project with forecasting of wind energy to optimize and balance actual power chains. And the other is computer vision that I also will share with you. It's everything related to reduce and increase the productivity of operation using some and increase the level of safety based on video recognition of people, some other defects, and so on. Okay, and in general, so we cover most of the processes with our product, starting from like the actual like digging and loading of the in the mining, in open pit and underground mining, up to processing and helping the operator to manage the processing plant. And before go to the details, so I would like to share why and how you need to like implement AI, because artificial intelligence, it's only the one like tool that won't work by itself. Even you have best algorithm, it won't work. So because you need to involve people, because still people are working with this AI and they control the actual equipment. Sometimes it's controlled automatically by a system, but what is important is that you have a proper team and make a culture, because innovation in AI, they sometimes, for example, the project might be not successful. And you should make this culture of fault. I mean, not a culture of culture of people who is able to fault and then make decisions and run like much faster in the new project. So it's it should be in your implementation. And yeah, when we're talking about artificial intelligence, we often talk about data, and we often talk about big data. And in mining operation where we're working, it's not a very huge data, but we still can consider it as a big data because there is a different sources of data, different velocity of data that is coming, and so different types of data and different databases. So in general, like a single mine can produce about 150 terabytes per year, but even more if we have a lot of video analytics. So then, I mean, this is like one of the research that we made with our colleagues, how many of data each of the system brings on a table during the year. And AI, it's more like bulk processing and algorithm that try to receive the value from the data that we're storing. There is another, maybe it can be a lecture or how should be data stored, processed, then whether it's better data lake or data warehouse and other things. But in general, so today we would like to show the cases that we have made on our platform, and our platform is built for production guys. It's more for people to use exact applications and that help to decrease carbon emissions. And one of our products is a truck driver assistant. And the truck driver assistants help to reduce fuel consumption that directly influence on the reducing of CO2 emissions. And it has a few features, and I will talk more about that. The features are augmenting the drivers in real time. I mean, showing them how to drive. So it's still not, it's like a GPS in your car maybe, but like showing more applicable for mining. Then we have a road quality analytics, we have truck technical condition evaluations, meaning that depending of how good your maintenance of the truck is, so you can it can consume different amount of fuel in the same road, so also can give this analytics. And of course, when we monitor and want to reduce something, we need to count and monitor all the statistics of that. So meaning that here we more work with the fuel consumption and tires, so we need to understand how we calculate and manage it. So what problem we found out that the qualified drivers may save up to 15% fuel and drive faster, and due to proper speed, acceleration, and gear and steering selection. And an average mine, for example, for your reference, with only 50 mining trucks, consume more than $30 million per year for only fuel, and provide about 200,000 million tons of carbon emissions. Meaning that it's huge. I mean, there's only one single mine. And of course, when you save fuel, so coming back to the beginning of presentation, so there's two things. One is, in general, carbon emission savings, but this brings, in the most of the cases, brings some efficiency to mining. So both benefits. So you save environment, and you, most of the cases, might save some money. And what is important, because not all of the mines globally or companies globally commit to this zero target. But what we're doing, we tell, okay, so you will save your money and you will save environment with our solution. And this is important because not each single company are really ready to pay for environment. Unfortunately, this is true that not all of our global companies, even the smaller the company, they pay attention to environmental and unfortunately safety. So that's what I know based on my experience at least in mining and metallurgical plants. And what is how we help the actual mines to save fuel and carbon emissions. So as I told you, augment the driver. So have real-time audio and visual devices for truck operators, and they provide optimal performance suggestions. Okay, when we need to accelerate, when we need to turn the steering wheel, and so on. Then we have a truck condition report. It's where we compare the same models of the truck that consumes less or more fuel during the operation. Then we have the road quality monitoring, because if you compare with if you're a driver, so you have a driving license and you drive, sometimes you know that if you drive smoothly, so your fuel consumption is much less. But if you start, for example, in the city, so in the intersection when you have a red light, so you stop, then you accelerate back, and then you consume much more fuel than you go smoothly on the highway. So the same here, if you have a good roads and good conditions, you will be more efficient in fuel. So that the system automatically show it to the mine road maintenance team, so they can fix it. And of course, one of the important thing is to evaluate how the drivers are being how they perform in case of efficiency. Here are some examples of the tools that we're using, and this can be a regular a tablet that is installed on the dash of the truck, or it might be a display, head-up display with a projection on the screen. And of course, there should be visual visualization. And where we have machine learning algorithm there. So of course, first of all, we need to collect the data. I mean, it's obvious to make some some processing of data. You need to collect it. So, and this computer that I show, they connect to interface of the truck and collect all the information that is required for our models. Then we apply AI models, and AI models that first of all predicts the fuel consumption based on the environment, and then they calculate the optimal driving profiles. And what is important, that you need to automatically update it, and this is self-learning models that continuously improving their quality. And then actually we send these models, and from these models we make kind of GPS with some checkpoints where we notify the driver that how he needs to operate. And so if we a little bit summarize, so we take all this or make it more simple. So the mining truck operator that drive these big trucks on these mining roads, and then we collect all the parameters. And then in reality, the AI algorithms see the best optimal, they make a synthetic or virtual best driver, and then apply this information to all of the drivers. So we enable best practices for driving in a certain part of the roads for all drivers. So because there are some new drivers and old drivers, and all of this might be very different. And but this is still not autonomy. So as I told you, I was working for a few autonomous projects, and then it's very hard to implement. Because full unmanned truck, it's a safety issues, it's cost issues, and legal issues in different countries. It's a labor unions, and but we tell, okay, so what if we try to use the algorithm or that manage and control autonomous trucks, and just give in the beginning recommendation to a driver. So that's what we did implementing our driver assistant. So this is a small video. Let me know if you see it. Yeah, it should work right now. This is a very small video, just for example how it looks like. It's a simple version of the head-up display, and this shows in real time your speed, your actual and your recommended speed, then smoothness of driving, then if you need to pull the throttle or you don't. So and it's very simple to use for a driver, and you don't need instructions for that. Then it's more or less the same, but there is how it's installed on the manual truck. Yeah. And as I told you, we make some kind of checkpoints map, and this map that gives, so it's a virtual, so the actual driver doesn't see the map itself because it usually is not required. So we have acceleration and brake points, we have speed checkpoints, and then per each zone recommended speed. And when the truck goes, so we also make a voice notification, turn ahead at 20 kilometers per hour is required speed. So this is some example, also some video. I won't go to many details, just to to give you some highlights how the system looks like. So yeah, the one part was regarding driver assistant, so the actual interface for the driver, who is the key user of the system, of course. And then when you implement any solutions, it doesn't matter if it's AI or not AI. So you need to be sure that you know who will be using the system, because AI doesn't bring you any efficiency. And this is a totally different story. So you might apply some AI algorithm for some applications, but this, you need to understand who, for all of the screens, who will be using these screens, and what are the how the screen will bring the efficiency to operations. For example, why we need the particular screen when we have all these commands to show that, okay, so here is the gaps. The gaps is the technical condition of the truck. And when we have all this article that AI will bring $1 million US dollars to a mine, or reduce dramatically carbon emissions of whatever industry, mining, metallurgical, or power supply, or energy. So it doesn't mean anything, because you need to have all the value chain. How this data, for example, here's some data, so that was processed to make this mind map of the road, to make any of this report. So this AI is there, but then who will be using and how to reduce the actual carbon footprint. Yeah, and so of course, then when you make a system or make a prototype of a system, you need then to install it, and then you need to discuss how all this is being installed. For example, which wireless system, which sensors do you need, and so on. And yeah, we have some actual case studies, how it helps. And when this is a photo of from the drone of the actual mine where we implement the system. This is iron ore, huge mine actually, and we have about 5% reduce fuel consumption and increase the average speed. So this helps, and in reality, we're in the same time for the actual hauling part, and hauling part it's about half of carbon footprint of the mine. So we reduce, say, by 2.45% the whole reduction of mine carbon footprint. And so then the other case study is for one of the gold mines. And what is also important, that when you're implementing any of your AI-based solution. So the efficiency won't come from like the very beginning. So the efficiency comes like step by step. So when you have initial efficiency after first testing, when you have a stabilization of the system, what does that mean, stabilization? When the people start using and understand actually how to use all the features, and then you also can achieve in some other like maybe half a year when you use in reality all the features of your system. And that's what we face in one of the gold operations. Okay, so this is initial efficiency, so you can feel it in the beginning, but then you need to work more and more to achieve better results. Okay, so this one part I finished, and yeah. So Jon, I hope I pronounce your name correctly. Okay, so the question regarding autonomous trucks. So for autonomous trucks, based on my experience, the payback period, it depends on the country actually, because in reality, the autonomous trucks save the labor cost. And if the labor cost is low, like in most countries of Asia and East Europe and Africa, actually, the labor cost is rather low. Of course, it brings some more efficiency on mining operation, but in reality, say it's like up to 2-3 years. It's for implementing autonomy when you buy new trucks, when you not retrofit, because retrofitting is not the best option for mining, only for mining trucks, only for when you want to make a pilot. So then it's better to buy a new truck that's ready for autonomy. And the payback for autonomous trucks is about like 2-3 years in reality. In our system, the payback period is less than 1 year, because we are not 100% autonomy. We're a system who augment the driver, but the driver is still inside the cabin. Jon, so let me know if it's okay and we can proceed, or any other question as well. Okay. Okay, so I will move forward and give you some more cases. Okay. Of course. I mean, we have maybe a little bit less efficiency, but it costs much less in our solution. But usually it's less than 1 year, maybe maximum up to 1 year. Okay, thanks for the question, and I will come back to because I don't actually see all the questions when I present in full screen my presentation. So that's why when I finish the actual part, then I will be doing answering the questions. Okay. So another products that we're having is a tire management, and why it's also I think it's scope 2 of carbon emissions for mining, because it's not so the tires itself, they don't produce any carbon emissions while operating. Maybe some small, but I mean in general you cannot manage it. But when you buy the tires, and the more to produce a tire, you need the oil and all other information, all other energy to be consumed. So, and the much less tires you consume, and the bigger will be life cycle, the less carbon emissions will be produced by the manufacturers. And and why it's important for mine to also work on the tire life cycle, because it's the second cost of the operation of the truck after fuel. And for example, this tire may cost like up to 50,000 US dollars. Like say it's for one of the biggest truck. Say this one single tire costs like a Tesla. Meaning that if you usually the mine's operating 24/7, and they need six tires per year in average so you can buy 6 Tesla. Actually, you can buy new Tesla each 2 months and just throw the previous away for the cost of the mining trucks for the year. And of course, when we manufacture it, these huge ones, huge tires, we produce a lot of carbon emissions. Yeah, this is coming back to your questions. So this also pay back for itself very quickly, like half a year, up to 1 year, because we, as I told, these tire costs are very high. And there is also some AI algorithm, but in reality much less of them. We only like predict life cycles and how many tires you need to buy. But the system architecture more or less the same like in the previously. You installed some sensors on your truck, and you collect all the data, and you also have some mobile application, but not for a driver, but for tires engineer. I will show you a small video regarding that as well. And then, of course, the system gives some recommendation about how to manage tires, and we have two types, as well as in the previous digital advisor for truck driver. So we have a tires engineer application with all this mobile checklist when he need to make a photo of inspection, and in general we collect manually, half manually, some information. The other information take from the sensors, and then we give some recommendation. And the recommendation how to manage. For example, these big mining tires, you need to rotate from left to right or from front to rear wheels to increase the life cycle. And then, of course, we calculate all the KPIs, how is it being operated. And then we one of the important things that we do is we calculate the cost and how much we lose or how much we have benefits from increasing and using the system. So it's very important because, yeah, as I told, the first thing that we're working and the mind wants to work on is efficiency and like savings of money, and it depends on the mine, of course, but usually then comes safety and environment comes. But all these should be together, and we try to increase the efficiency with reducing the carbon footprint. What is important here? So one of the things, most of the people, they don't work with different, they don't want to go with different applications. For example, in your iPhone or your whatever Android tablet, so you have installed 200 applications, maybe more, but you are using on a daily basis, you maximum use 10 of them, and you don't want to use more because it's already a lot of information. And we understood that, okay, how we can help to receive and give notifications much easier and faster. So we can do the chatbots and some other WeChat or WhatsApp, doesn't matter. And this information will automatically inform people much faster than in any other application, because you use it to chat with your friends or with your family or with your colleagues. And if you have any chatbots that you're using for your student life, so if you wanna to make any AI algorithm that notify about something, make a chatbot that will inform everyone automatically. Then they can go for a system or make some dashboards, but yeah, this is what we have for now. Even industrial systems should be with chatbots, but still to manage the specific needs of in mining and some. So you need to make inspection of the tires, and this just small video that to bring some algorithm, machine learning or whatever. So you need to collect the data, and still, so not for everything you can collect the data automatically. And here is we have one of the example of our application when you have your electronic depth thread meter, and you can actually come to a tire and make all the measurements much faster. Yeah, this is the example. So you just come to a tire, and this all the information automatically goes to counting system. What is also very important? Very important is to make it easy to use. Meaning no one will use any system like with machine learning algorithm if it's not easy and simple to use and doesn't have a friendly interface. So you should work on the design of your application. Otherwise, no one will use it. And for sure, if you can make it closer to Instagram or Facebook or TikTok, whatever the application you are doing, the better. Because if you make it simpler to people who already use a similar application, it will be much easier. And why? One of the other things that is important in any of these applications, that if you make any suggestions and any recommendation for some people, it can be drivers, tires management, or whatever, road maintenance people, then you should collect the data, how it's being executed. And if you, for example, with the tires decided that you need to make the measurement of the depth thread each 2 weeks in each tire, so you should do this. Otherwise, you won't have any result. And then this, in general, dashboard goes to top manager, and so he can see how good their managers and engineers and other specialists are working with the system. Because once again, before we have fully autonomous operations or fully autonomous oil processing plant or any chemical plant and so on, we still have some people that we can just suggest and then monitor how they perform. And all the human factor, the huge may have huge influence on the operations of any of the industry, and actually also finally, if it's not efficient, brings higher carbon emission. Yeah, in some case study, actually, this is also the photo of the mine there where it was implemented. It's also an ore mine. And actually, we achieved very good results with this case study, increasing the life cycle by 12.5% and saving in reality huge amount of of these tires per year. Yep. So yeah, this is all for this part. Any questions? Yeah, so regarding GHG emissions cost in the calculation, so it depends on the country. For example, it depends on the legal, say for example in Russia, we have our from 2025, the company just start paying a little bit more on the carbon footprint. For example, if they achieve a certain level of the, first of all, no one knows now how to measure. For example, if we, for diesel power, it's very easy. So for example, you consume like each liter produces 6 kilograms of carbon CO2 emissions. For example, it's easy. Then when we're talking, we started working on some ESG project with the eco monitoring of metallurgical plant. But there is no standard methodology because all the metallurgical plants are different. How you calculate the carbon footprint, and then so the first problem is you always cannot directly measure the carbon emissions or any other chemical emissions. So sometimes, I mean, you don't have, or you cannot install sensors, or they're too expensive for now. So it's the first problem. The second problem is say you have this baseline, so you install all the sensors, but then depending on the country, some companies just, for example, in Australia, there is strict requirements to reduce the carbon emissions. Everything is set up and all the methodologies are there. But then when Rio Tinto, that is a global company, comes to Africa, they might do, because it's global standard of Rio Tinto, they might reduce these emissions. But in Australia, it will give the benefits, economical benefits, because it's not only saving the fuel, but as you mentioned, so it's reduce of payments to government, or for example, when you exceed the limit of the carbon emissions. But at the same time, in Africa, some of the countries, there is no any legal, like acts or any rules regarding that. So it won't bring any additional efficiency. But sometimes we start doing that. So in general, not all of the companies, they think about like payments, because there is no any legal issue for that. So, but some of the countries, they're moving to this direction. Yeah, it's complicated. But it should be in consideration, I think, for the next 3-5 years. So it's coming, and in many countries as well. Okay, so yeah, if you're still with me, I have a few other topics that I want to share with you. Also based on AI. Let's go there. So one of the system that we're doing like for underground coal mines, it was like a methane level prediction, and it's not for safety. It's more on reducing the cost of operation, because safety is already, so there is a system that already has, this is actually how it looks like. It's if you never saw the pictures of the underground, the continuous miner. The continuous miner, they just like dig a coal with this like whatever round, and then brings by a conveyor belt to the surface. And so what's the problem? So there is a safety system that measures the methane level, and if it's achieves 1% of concentration, it automatically stops all the machines and all the conveyors and so on. And then you need to stop for another half an hour to 1 hour to wait until all this ventilation will remove the gas emission. And then by that time you don't work at all. And what we decided to do with one of the coal mines, underground coal mines, that what if we can predict the methane level in 1, 3, and 5 minutes only, and then can reduce the speed of digging and crushing with discontinuous miners, meaning that when you reduce the speed, the actual coal, because coal produces methane itself, and it will produce less methane, so the automatic system won't stop the operations, so you will go up to the top level of the, but that is still in the green zone, so you still can operate, and then by this half an hour that previously you need just to stop to make a ventilation, you will work maybe on the half percent of your productivity, but still will work. And yeah, so we have collected, I think it's about 100 different sensors, but not all of them are used in AI modeling. In predictive model, the system will give you the information of which sensors, for example, is important to make, for example, we have acoustic sensors, but acoustic sensors didn't give us any information that is correlated to methane, and seismic events that is really like very rare, so it doesn't measure each second, but most of the data we measure each second, and then we apply different algorithm to make a prediction model. And what is also important, this is actually schematics of the mine, and so the actual this big continuous miner, its go like from left to right of bottom to top, doesn't matter. So goes this way and others, and you have a different sensors that measure this level of methane. And then what is important in any AI? So the mathematics or algorithm or statistic won't give you a clear result if you don't know the physics and methodology of the process. What does it mean? That, for example, the air these red arrows comes that way and go through all these shafts, then go to the actual operation. This is, for example, position of the actual miner itself, and goes back and forth. Then all this air with gas goes back to ventilation. So some kind of circulation inside the mine. And the problem is that the time that the air comes from the first sensor number 1 to the sensor number 11 can be half an hour. It depends, of course, on these dimensions of the mines, but in reality, if you don't know that, you will compare these measurements with these measurements at the same time, but you need to understand that these measurements will influence on number 11 in the next half an hour. And if you don't do this, so your mathematics won't give you any good results. So just need to take into consideration, and then this is one of the interfaces that we have. For example, this is a level like 1% of concentration as at all, and this is the actual green line is the actual level of methane, and this was the predictions. And the one of the important part was just to predict whether it will exceed the limit or not. And as we discussed today, it's partly from safety, but I mean there is another system that monitors the methane. But we actually give the additional production time of this coal continuous miner, and this is actual 3D model of this continuous miner, ACOF. As we produce more with the same equipment, we produce more coal. So it will actually about 1 year of payback period. Yep. So yeah, maybe another questions. Okay, so if not, yeah, we still have some time, so I can move forward, I think. Yeah, just a second. Yeah, in computer vision. So computer vision actually it's one of the thing that brings a lot of efficiency, but still requires a lot of developing and a lot of a lot of hardware and powerful video cards in that. So and this is very important because it uses usual neural networks. It can be on a server or it can be in different devices, but still, so you need a lot of resources to do that. And yeah, we make a few cases that bring efficiency for mining. For example, this is an excavator that working on the mine, and we automatically in real time detect if there is a teeth on the bucket or there is no, and it's break. Why it's important? Not because you lose the teeth, because if you lose these teeth, then it goes to truck, and then from the truck it goes to crusher. Crusher meaning that where you make your ore smaller, and then it can break the crusher and break the whole conveyor belt. So that's why it's important to do that. So then, and all this like we made automatically. Then, so we have a system that calculates how the shovel is operating. I mean, usually to control all the cycles and monitor all the cycles, you need to install different sensors. And what the problem with the sensors that you need to maintain the result of cables, but having video analytics, we can just monitor it with one single camera. Yeah, this is a fragmentation on in different parts. So for example, we have a fragmentation and can measure. Fragmentation means the size of these stones or ore, and this size usually. So you need to optimize it because based on that, your efficiency and productivity of the shovel, and actual, if you are not productive, you consume much more energy for electrical shovel and much more energy for crushing. So it's also like not directly, but influence on the carbon footprint. The same with underground equipment, and we also can understand whether it's loaded or not. For example, if it's loaded not properly, so you can it decrease the life cycle and increase the maintenance cost. Yeah, one of the other thing is to measure the volumes and the fragmentation in the body of a dump car or body of a truck. And then if it's not loaded properly, then you can notify your operator of the shovel to make the next loading proper. Yeah, and fragmentation on the belt, as I told, the fragmentation on the belt, and this is actually the real photo, so we detect with different colors, different sizes. So one important thing with the conveyor belt that you can manage. So when you're talking about shovels, there's still people inside the shovel and or excavator. But if we're talking about like a conveyor belt can be managed usually automatically, and so you can make a fully autonomous conveyor system like management because it's easy. You can just manage the speed of your conveyor based on fragmentation. This is widely used in the mining. And I'm supposed to have some video here, but okay, this is very nice stuff, but unfortunately I don't have video for now. And this is flotation process optimization. Flotation, it's how to say in simple words. So for example, you have any like can, whatever, and you put some ore, for example, iron ore or gold ore, and then you need to extract the ore or the gold ore with a good quality. For example, when you can extract the actual gold out of it and waste. And there is big cans where you put all this ore, you put some bubbles, the actual bubbles with the air, and you put some chemicals. And when it starts, you may call it boiling, like a soup in your kitchen. So the good, like the lighter parts of it, they go up and out of this can, and the other goes down. And what is important is to you need to monitor this process in real time, and usually it's made by a person. I mean, visually they see the size and the color of the bubbles and how they frequently they appearing and disappearing, and then can control the truck. But with the like computer in real time, see the how the bubbles are operating, what are the size, and then you give all this information also to automatical management system. Yeah, this is also will bring additional efficiency to operator, because you with the AI, and this is true like 100% AI system that gives efficiency to operators and save the chemicals as well. And another in general this video recognition system or computer vision, that like might be costly, because if you have a special feature, for example, like we did here, it's so you produce some metal parts, and so they were painting. There was a painting machine that should paint like say like 10 centimeters from each sides of this part, and if it doesn't work well, or if there is any problem with the machine, so then the product quality is not acceptable, and there was a lot of defects and on the manufacturing line. And when we install, because they were manually also trying to understand it, we install the computer vision system that shows in real time if there is any defect, so you can stop and fix everything in real time. And there is another, so how actually the neural networks and video recognition works. This in ideal situation, if you wanted to detect a cat or a dog, so you need to have pictures and photos of the dog. Then you should like make detection of this, like in paint or whatever. You can draw that. Okay, here's the dog. You should mark it on the each photo. For example, hundreds or thousands of photos, and then you should like send it to neural network algorithm, and then it will next on the 1000 first like picture, the neural network will understand that is a dog or a cat. So that's how it works. So you train it, and then it can detect with, of course, certain quality. It can detect the information, but then there is something that you cannot do in advance. Meaning that you need to detect anomalies, meaning that there is something that unusual, and there is different types of the neural networks that can detect these unusual things. Meaning that there is you cannot know that which kind of breakage of the conveyor belt will occur. But you know that the system know that, okay, there was a solid part, and the actual, in general, the conveyor belt is solid, but then it starts breaking, so the system can detect that something happening with this material. It means, for example, if there is a camera that goes and looks into the whatever street, and something comes and detects that something is going wrong, so some object is inside, but it cannot tell you what is it, cat or dog or a human or a person, because it is not trained, but can tell you that something goes wrong. And this is more and more used in the different industries. The same with the oil cable. This is one of the case study. We have oil cable, and it's very long, and there is some drone video that we processed and see if there's any anomalies and potential defects of cable. And one of the other things that is simple, really, this is counting, different counting. This is for pipes for the manufacturing, so it's easier to do this counting based on the also video or photo. And the other thing that is for metallurgical plant that can detect how this iron ore and feeds from one place, from bucket to like some cans, and so the idea is so you cannot physically install any sensor because I think it's about 800 degrees Celsius there, but computer vision helps with that because it's rather easy to detect because it's different lights and colors. Yep. So thanks for the question, Dalia. I hope also pronounce your your properly and correctly your name. Parameters. I will come back to the method prediction slide, if no one minds. The question, in general, for sure, the important is methane level. So the methane in different parts, when it comes to underground mine, goes inside and goes out. Ventilation, air velocity. It depends on which kind of ventilation, whether you can modify the speed of ventilator or not, but it's important. And this is up to particular mine. When you have a different mine or different operation, it can be different sensors installed. But what is in general process? You need to check the physical process, how the airflow goes, and which sensors you have. Then you apply it to model, and model will give you the parameters so that first of all, if the amount of parameters are enough to make a prediction, because if you have one sensor, for example, like 10 sensors, it might be not enough to predict, or the quality will be very low. And then, but in our case, coming back to our case, we have the position of this continuous miner in the shaft. We have the actual speed and load. I mean, it's a pressure and the currents in the engine. So I mean, how fast it goes and how deep it goes when he cuts the coal. So that's what we have from the actual machine itself. Then we have a conveyor speed, because when the coals go out, it goes through conveyor, and depending how fast the conveyor goes, it also influences on the methane prediction. And I think there's mostly everything that we have. So all these acoustics and seismic, doesn't give us any. I think the model was built on 12 parameters finally. 12 origin raw parameters, but of course you, for example, tell, okay, one parameter can give you 10 other parameters, because you can tell, okay, these parameters 1 minute ago, 2 minutes ago, and so on. So it means that raw sensors. Okay, welcome. Yeah, and I have the last thing that I'd like to share with you. Yeah, this case for wind generation, and so what's the problem? So in general, it depends, of course, on the country actually, and on the how the electricity and power, all the grid and networks are being built. But in general, if you make any power plant, you should agree, because you may own the actual power plant, or you may own the grids that transfer this power, the power lines. And then you have, depending on the country, of course, then have aggregator who can then sell it to other customers, and they should usually balance the load. So if you tell, okay, I will produce a certain amount of kilowatts per hour, and then if you produce more, so they cannot achieve it, but you also cannot store it because you don't have enough batteries, for example, or it's too costly. You just need to directly supply it to the power line. Or the other thing, if you're under the production plan, so they can give you the penalties. And the biggest problem in the wind generation, when you don't, depending on the weather forecast and the wind forecast, what will be your power generation. And then most of the wind farms, they try to do it manually or with some mathematical formulas, with some applications or software. But what we did, actually we make a real good forecasting model that gives the information of forecast for 1 day. And I think that let me remind, I don't remember whether I have this this information. I think the accuracy is about up to 90% of this forecast. And then so we make a dashboard, and so in reality they can, before implementing our solution, this is one of the dashboards of the system, they can predict manually or with some formulas, with some software, with the error in about 20%, and we reduce by 2 times, so we have only 10% error in forecasting. And it can be, of course, decreased because the accuracy could be improved, but the more data you have, the more information and the better is your model. Yeah, and this is some example that you can fully use your equipment and produce stabilized operations. At least forecast, how much you will be providing based on the AI. And so there's a few slides that I would like to share as well. So I had experience of building a big team internationally, and I have many people. This is actually one of the workshops that I made in one of the mines with all the international team from, it was Africa, Peru, Chile, United States, and I think India, Turkey, and some other countries. We came to our internal workshop, and it was really great. But we have a lot of online now, but still, it's according to physiology and of people. So you still need to meet in person because you can feel much more than in a web interface. And so you need to risk, but you risk responsibly. When you do something new, AI is new. It's new for and more, or it's for heavy industries like power supply and mining. It's really very new. Yeah, they're conservative industries. So you need to motivate the people to risk, but responsibly. And in different locations, and it's me on the left, very young, like 7 years ago, whatever. Connect people and respect local mindset. It's for sure different. The same application with the same AI tools might work with one country and another not. And what is important? So the customer doesn't mean the customer who buys from you something, but it may be internal customer. For example, the IT team is a customer of business analytic who give him the information. So you should be always focused on doing best for your external or internal customer. And you should be friendly. It really helps, and all this parties and corporates really bring some efficiency. And you should, in a mind, you should be a leader because you do something impossible. And even you're a small company, and we were a very small company. Now we're about 70 people, but still relatively small to ABB, whatever, even IT part of ABB. So you should always focus to do that. You believe in impossible things that you can achieve. And this is a holiday in India when you paint, go to the streets and everyone paint each other. And it's important that you work hard or you study hard and then you play hard. Thanks for your attention. We still have some time if you want to ask some question. Here is my contact details, so you can ask the university to provide it. And hope you enjoy today's lection or workshop. I better show it workshop. Thanks. And if you have any questions or would like to have more info or just to chat, just let me know in email or whatever. Keep in touch. Have a good week. Actually, today is Monday. And wish you good luck. Thank you so much. I think I should stop it somehow.